so for today's lesson, we're going to talk about doing indirect proofs. And an indirect proof is just a proof in which a statement is proven true by showing that its negation is false. So essentially what that means is, if you were to try to prove that some statement P is true, you're going to assume that not P is true as line 1. So we're going to make an assumption. We know that making assumptions are bad, and we're going to be able to use this assumption, go through the proof, and we're going to be able to show that there's some sort of contradiction within the body of your proof. If you can do that, show a contradiction, then you can conclude that your assumption, not P, really is false. And if not P is false, then regular P must in fact be true. Sounds kind of confusing, but I promise you it really isn't. So this first proof that we have here, we want to prove that C is true. But because we're proving it indirectly, we know that the first step is always going to be the assumption of what we know is supposed to be true as C. So because C is our proof statement, we're going to take C and negate it, and we're going to assume that not C happens to be the true one. Okay, so we're taking the negation of the proof statement. So not C is our first one. And then from there, as you look through your proof, the only next thing that works with the not C is your if G, then C. That's given, because now we're back to regular old proof stuff. From 1 and 2, we can use modus tollens, and we can get not G. And then from there, we'll go back to our given, which we haven't used, which is the T or G. And then by using disjunctive inference, from 3 and 4, we can say that because not G and G are opposites, that T must have happened. Bring this down a little bit. And then we go back to our givens and we say, well, we also have in our givens, though, not T, which is supposed to be true. So here is where you find a contradiction. You can't all of a sudden say T is true and then say not T is true. It doesn't make any sense. So then what has to happen is, because we found a contradiction in lines 5 and 6, that positive C, what we wanted to do, really has to be correct. Okay? So we're trying to do it that way. So we know that not C was our assumption, and as we go through the proof, we find a contradiction in 5 and 6, which means not C, the assumption is false, and regular C is in fact true. Okay, so let's try this next one. So we're looking to prove F. So we want to assume that not F is really the true statement. Always in an indirect proof, your first line is going to be the negation of the proof statement, and then it's always going to be by assumption. Then using not F, you know that you have F or S as given. And then through disjunctive inference, you have S being the true statement. And that's 1 and 2. And then if we go back up to our givens, we can now use if S, then B as given. We can detach off the B. And that's from 3 and 4. Bring this down and extend this up a little bit. So then the next thing is going to be if B, then not P. And that's given. And then using not modus tollens, using detachment again. From 5 and 6, we know that not P is correct. And then if we do 8, the given, which is P, we found another contradiction. You should always be finding a contradiction within the body of your proof. So the fact that we've got this contradiction contradiction is 7 and 8, then we know that the assumption, not F, is the incorrect one, and then regular F is correct. So by contradiction from 7 and 8. So take a look at that one. Okay? So again, the assumption, the first line, once you get that down, you need to use that as you do the rest of your proof in order to find yourself a contradiction. Okay, last one. Slide this back over. Alrighty. So we're going to start off with the assumption, which is going to be regular D, because it's in the negation of the proof. And then using that, we're going to move next to if D, then C, and that's given. We're going to detach off C, and that's with 1 and 2. And then we're going to use, the next one's going to be parentheses A and B. If A and B, then not C. And that's given. And then this is a little bit trickier to see, but if you take a look at highlighter, if you take a look at what's happening here, you've got a negation with your conclusion, so you know that what's going to happen is the modus tollens. So modus tollens says I'm going to negate my hypothesis and that's from 3 and 4. And then we get to use De Morgan's law. So what do you do here? You're going to distribute in the negation, negate A or negate B. And that's going to be your De Morgan's law. And that's just from line 5. Bring this down, raise this up. Go back to your givens and you see, well, A, or also B actually. So A is a given and B is a given. It doesn't matter which single letter you choose, they both will work just fine. I'm going to go ahead and I'm going to choose the A. So if I use A as my given, then by disjunctive inference, you're going to be able to pull out that not B is correct. Again, that's from 6 and 7. But then the given that you have of B being true is where you find a contradiction. So then what is happening here, I'm going to raise this up one more time, the fact that B is true, then you've got a contradiction in 8 and 9. Therefore, when we said that not D was correct, that D was the assumption, then not D is in fact the true statement. So this is because we found a contradiction in 8 and 9. So again, you could have chosen as your line number 7, B as your given, and then not A would have come out, and then you would have used A as your given, and that's where your contradiction would have been. Okay, so let me see if I can kind of show a full page of this. Does it show up? Not so well, but I think you guys got the picture. So good luck on your homework.